the difference between dry and wet storage lies in the different level of humidity of the place where you store your tea. But is it really true? The answer in this video. Hi guys, this is Gabriele from nannuoshan, where we share the pleasure of drinking and discovering genuine farm tea. If you're also here to expand your tea knowledge and brewing skills, make sure to click on the subscribe button if you haven't done it yet, and give us a thumbs up if you enjoy what you're watching. So today we are speaking about Pu'er storage. In a previous video about Pu'er storage, I went through the different aspects actually of the environment that influence the aging of the cake. Things like ventilation, light, humidity and temperature. In that video we made also a very clear distinction between dry storage and wet storage. And of course the difference between the two is that a dry cake is a cake that was stored in a dry place, and surprise surprise, a wet cake is a cake that was stored in a place, in a location with high humidity. But at the end of that video I showed you in a table the average humidity of different locations in China that are known for different type of storage. So you have Hong Kong, that is a classical wet storage place that have a humidity of 77%, so fairly high. And then you have Kunming, that is rather a drier storage, much drier than Hong Kong, that has a humidity of 71. So a little bit less, but the difference is just 6%. And then if you look at Shanghai, Shanghai is actually also a dry storage, but the humidity is even higher than in Hong Kong. It's strange. And then we have Beijing with 57%, which is lower than Hong Kong and is also very famous for being a place with very, very dry storage. So somehow it seems there is not a very clear correlation between the level of humidity and whether the storage is dry or wet. But I can tell you, a dry cake is really dry and a wet cake is really wet. So what's the point if it doesn't correlate well with the humidity? Well, I asked this question myself as well, and we have done some quite research on the topic that I would like to share today with you. So to do that, we will start speaking first of all about the environment in which the cake are stored. So what do I mean by environment? I mean, like, humidity is one aspect of the environment, but is not the only one. Which other environment could play a role? Let's look about the temperature, for example. Let's look at those four cities that I told you before: Hong Kong, Kunming, Shanghai and Beijing, and let's look how it is the average temperature in those places. So you have that in Hong Kong the temperature is fairly high, is about 23 degrees centigrade on average during the year, while in Kunming the temperature is a little bit lower, let's say about 18 degrees, and then in Shanghai is even lower, it is 16, and in Beijing is even lower, is 13. So somehow it seems that the temperature correlates a little bit better with our experience of dry and wet storage. So is it really about temperature, and why temperature should really affect if a cake is dry or wet? I mean, we know that if a climate is hot, it doesn't mean that it is wet or dry. You can have a very dry summer in the desert, and you can have a very humid summer, and we know many places that really this summer thunderstorm can be very humid. So it's not about the temperature apparently, but well, you have to know that temperature indeed affect also humidity. So this is a bit of an advanced concept, and I will tell you during this video we will go deeper and deeper into the world of humidity, temperature and other factors. But as a matter of fact, for a given relative humidity, the absolute humidity of the air increases with temperature. What does that mean? It means that at high temperature, so if you want warm air is able to retain more water than cold air. Let me do an example so that we are really 100% sure that we are all aligned on this topic. Let's pretend that the humidity, the relative humidity, is 70%. Okay, fairly high, 70%. And now let's say that we are in a cold place and the air is at 15 degrees centigrade. Well, 70% relative humidity at 15 degrees centigrade means that in the air there are 9 grams of water per cubic meter. Now, if you keep the 70% and you increase the temperature of the air to 35 degrees centigrade, so a very hot summer if you want, then the amount of water in the air is more than 3 times as high, is 28 grams. So you see that even if we have the same relative humidity, 70%, the amount of water in the air is much, much higher as higher we go with the temperature. And this is the point, right? So you can see it also in this table, how at different temperature, moving the course from blue to red, you see that the amount of water, amount of moisture in the air is actually higher for the same relative humidity, and higher by quite a lot. So now that we have introduced the concept of absolute humidity, that is really the quantity of air that you have, the quantity of water that you have in the air, we should look at the absolute humidity of those 4 cities that I was speaking before about. So what about Hong Kong? The absolute humidity of Hong Kong is fairly high. On average, there are 15 grams of water per cubic meter in the air. Kunming and Shanghai, interestingly, have a similar amount of water, more or less both around 11 grams. And then you have Beijing that has much, much less water in the air. On average during the year, 1/3 of the water that we have actually in Hong Kong. Well, Hong Kong is definitely, in terms of absolute humidity, much more humid actually than Kunming and Shanghai, because it has about 50% more water in the air. So these to me correlate maybe even better actually with our experience with dry and wet storage, where Hong Kong is really popping up as a lot of moisture in the air, Beijing much, much lower, and Shanghai and Kunming that have both a fairly dry storage lie somewhat in between. So at this point we have to ask ourselves, shall we look at absolute humidity instead of relative humidity when we want to know how our cakes stored, for example, at home will develop over the year? Well, what I can tell you before going further in the discussion is that certainly absolute humidity seems to be a better I would say, reference, if you want, with respect to relative humidity. So it seems that if we look at the absolute humidity of where our cakes are, we have a better idea of how those cakes will evolve over time. So for sure it's a better indicator. But why does it make sense? Why does it make sense? It makes sense because it means that if the temperature is higher, so the absolute humidity is higher in the air, we have more water in the air. This means that also the moisture uptake of our cake will also be higher. And what does water affect? Well, you know, water affects a lot of processes that have to do with aging of the cake. It affects microbial activities, it affects fungi development. So the more water, the more fungi will develop, and the more active will be the microbial activities actually. But not only that, also pure inorganic chemical reaction, like for example oxidation, increase at a higher rate at higher temperature. In some situations, they even don't occur at all if the temperature is low, and they start really occurring only if the temperature is high. All these processes, microbial activities, we said fungi development, so fermentation, we have also, we said, the chemical reaction. All these happen much more at high humidity, at high water content, and that's why this makes sense. Nonetheless, there is actually more to say to that, because the reality is even more complex, and we will go one level further in this video. So far we have spoken about actually the environment around the cake, but we will have also to speak about the tea leaves and how they actually interact with the environment around them. So what do we have to say about the tea leaves? First of all, there are different materials that have different capability of absorbing water. So take for example a sponge. A sponge is a material that is able to absorb very easily water. But if you take for example a piece of glass is not very good at absorbing water, not at all, right? So in a similar fashion, also the tea leaves have their own capability of absorbing water that somewhat lies in between a sponge and a glass. So how can we describe actually this ability of the leaves of absorbing the water? Well, technically speaking, we can speak about what is called sorption coefficient. A sorption coefficient is actually a characteristic of our material, the sponge, the glass, or our tea leaves, that describe the ability of our material to uptake moisture. So the sorption coefficient works like that basically. The higher the sorption coefficient, the higher the moisture uptake that the material can have. So the sponge would have a very high sorption coefficient. Sorry about that. And now I'm steeping my pu'er because I'm getting thirsty. Here we go. So we were saying sorption coefficient, and now we have to think what happens to the characteristic of the material. Does the material remain the same when the temperature changes? We said, for example, that the air changes. When we go higher with temperature, the air, warm air, is able to retain more water. What happened to our material? As a matter of fact, science shows that most material, when the temperature increases, have a lower ability to absorb water. So basically what happens is that if you take a sponge and you bring it in a warm environment, the sponge will be less of a sponge and will lean a little bit towards a piece of glass. And the same happened to our tea leaves. So when you take our tea leaves and you bring them from a place that is cold to a place that is warm, they have less ability to absorb water. Now this concept may sound a little bit strange to you. You may think, why a sponge should be more a sponge at cold temperature than at warm temperature? I will try to explain that to you. So everything has to do with evaporation. So you have to see that way. If you have a sponge that absorbs water, if there is more water in the air, it will, and because it's hot, for example, it will absorb more water, but at the same time, since the temperature is higher, more of that water will evaporate. You know it very well when you do the laundry in winter and you hang your clothes and it's cold, it will take a long time for them to dry, while if the temperature is high, they will dry much faster because the water evaporates much faster. The same happens to your cake. If your cake is a very high temperature, it's basically always it has to achieve a kind of balance between the water that it absorbs and the water that actually evaporates. And at higher temperature there will be more water that evaporates, and so the balance is more towards less water. That's why a sponge at high temperature is less of a sponge. So why this matter? This matter because if we want to quantify the water, the moisture uptake of our cake, we cannot simply look at the environment. So if you want at the absolute humidity, at the amount of water in the air, we have also to look at the temperature of our cake to see if it's capable of absorbing a lot of water or just a little. Now, for those of you that are more keen in with the math and formula, we can put this in a formula. I will show that to you. If it's a bit hard for you to understand, don't worry, I will explain very soon. So the moisture uptake of our cake is actually equal to a constant time what we call gamma. Gamma is our absorption coefficient, the ability of the material to absorb the water, times the absolute humidity. So you see that the water uptake will be much higher when the absolute humidity grows, and will be lower when the absorption coefficient decreases. And now we have to find a balance between the two. So the question is, when we go high with temperature, we say for a given relative humidity, so let's keep the relative humidity constant, let's say 70%. For a given relative humidity, at higher temperature, we will have the absolute humidity will be higher, so the moisture uptake will tend to be higher, but we say that the absorption coefficient will be lower. So there will be a compensation effect because one gets lower and one gets higher. So which one will dominate? That's the big question. And I can tell you there are some materials out there, we're not speaking about leaves now, that actually more or less have a compensation. So when absolute humidity increase, because temperature increase, they have also a lowering of the absorption coefficient that almost perfectly compensated. For those materials, what really matters is only relative humidity, because when you change the temperature and you keep the relative humidity the same, the two factors, absorption coefficient and absolute humidity, compensate each other. What happens for our tea leaves? Well, as a matter of fact, I wasn't able to find in the literature absorption coefficient for leaves, and not even for paper that should behave somewhat similarly. If you find something on the web, let me know. But as a matter of fact, if we look how the absolute humidity correlate well with our experience of dry storage location, wet storage location, Hong Kong, and dry storage location, Shanghai, and even drier Beijing, I would tend to say that most likely absolute humidity plays a role. It means that the compensation of the absorption coefficient is only partial. So to summarize what we have said so far, we said that first of all that aging of pu'er is a complicated matter. I think everyone would agree at this point. We say that actually everyone looks at relative humidity, 50%, 70%, 90%, but actually that's a bit wrong. People should rather look at absolute humidity, but nonetheless, the increase of absolute humidity is not really proportional to how quick our cake will age, because that effect is reduced by the lower ability of your cake to absorb moisture, to uptake moisture at high temperature. If we really want to quantify this, how much compensation there is, how important is actually absolute humidity versus relative humidity, we would need to do actually an experiment, and we would need an experiment to determine the absorption coefficient of the leaves. It's possible. So if you are interested in that experiment, let me know and I will do a video so that you can do it yourself. Just be aware that for doing that experiment, you need a way of controlling the temperature and a way of controlling the humidity. If you have this capability at home, let me know and I will do a video to tell you how to do the experiment yourself. So, which is the key message of this video? The key message is that actually, I would say that you have to take at home is that when you store pu'er, what you have to look at is water in the air. Real water in the air, so absolute humidity. And this means also that if you want to influence your storage at home, you don't only have to regulate the humidity, like the relative humidity, but you will have also to regulate the temperature. This makes things more complex, but as a matter of fact, if you live in a cold place, it won't help a lot to simply put your cake in a humid place, because the temperature will be low and the amount of water in the air won't be very much. It might be more effective actually to increase the temperature a little bit. So in a future video, I will let you know and explain how actually you can achieve this regulation at home of humidity and temperature if you're interested in a controlled storage of your cakes. And I will also point out which are the advantages and disadvantages of this type of control, both humidity and temperature. Until then, enjoy your tea as I'm enjoying this Pu'er, and I will see you at the next video. Don't forget to subscribe our channel if you enjoy watching, and of course give us a thumbs up, and thanks a lot for that if you enjoy watching this video. Thank you guys, and bye bye.